So in previous class, we discussed Spark core, right? We just started what is Spark core, how to write a Spark core application, right? Yep. Today we'll see how to write interactive mode. Did we see how to write interactive mode? Let's, yep, this is my input file. Let me minimize this one. Oh, we discussed only SBT cell. Okay. So this is our Spark core project we created. In this we created SBT. We didn't load any Spark core related jar files. Let me find Spark core dependency. Go to first link. Here, click on this Spark. Here you will see Spark core project, and here latest one is 2.3.1. Go click on this SBT. Copy this SBT. Today what I am showing, I'll show both interactive mode as well as batch mode. So import the project. So what I'm writing one class. Right click on this Scala. Right click on this Scala. Go to, yep, let me create this SBT project. Yep, right click on this Scala. New. It is not showing. Let's wait to complete this SBT project structure creation. Yep. Right click on the Scala. New. Still it's showing. Okay. Close this one. Go to our project structure. Parkour. So this is our workspace. Let me open IntelliJ IDEA. Okay. Initially, after installing IntelliJ IDEA, you will see this one. Click on New Project. Scala SBT. Click on Next. Then here I am selecting Spark Core. Okay. Scala version 2.11x. Remaining is as it is same. Click on Finish. So it is created workspace. It is created. Oh, oh, sorry. Yep. Let me create this one once again. Project SBT. Next. So it is created different location. Let me select the location. So I want to create under C drive, user, under user, in this user. So desktop, we have this location. So we are creating all the projects in this location. So let's create in the same location instead of creating different location. Let's use core. Okay. and here select Scala 2.x version. Yes, same window. A project structure is created. Let's open this SBT. So I'm adding Parkour to this SBT. Okay, let's click on import project. Yep, project structure is created. Let's expand SRC. Let's expand main. Right click on the Scala. Here new. Here you will see package. Click on package. I'm writing com.qt package. Under com.qt, I'm writing Scala object. So click on Scala class. Give Spark and select here object. Spark test. Click on OK. So this class must client class, right? Extends app. Extends app. If you want to write main method, you can write main method. Then no need to extend app class. If you extend, just directly write first val conf equal to new spark conf alt enter. It will add that configuration class. Next conf.set conf.set and here set master name spark.master spark.master. Master is local. Next one conf.set spark.app.name spark.app.name. Spark application name is spark core spark core application. Next pass this configuration object to sc spark context val sc equal to new spark context and pass spark config object. Then once we got the spark context object, sc dot text file is a method. This method takes file as an input, then returns rdd. So val rd1. So sc dot text file loads file and creates as a rdd. Then we are storing that rdd into rdd1 variable. So what is the file name is I have file. So under batch 3 we have a data. So this is the file name comment.txt. So let's pass that path // comment.txt. Okay. So this is the file. We loaded file. Next one rd1 dot collect dot println. Sorry, collect dot for each and println. So what is this rd1 dot collect? It will read all records. From that, it reads each record and pass that each record to println. Println function displays displays the values in console. Okay. Let's execute this one. Right click on this one and here run Scala core test. let's once again run this one. So we got output, but this is mixed with log information, right? So here there is one method called sc dot set log level. Sc dot set log level. So we can set a log level. I want to display only warnings. I don't want any other logs. Then we can set sc dot log level, set log level, and pass parameter. So if you pass warning parameter, then it display only warnings. Let's execute this one once again. You will see after output you cannot see any other error information. Yep, we got it right. Next one, how to implement the same thing in interactive mode. Click on SBT. Here you will see here type console, press enter. It will start Scala SBT cell. Scala SBT cell. Okay, it is created. Scala SBT cell. Click on console. Then it will create Scala SBT cell. You will see Scala prompt. Okay, it displays Scala prompt. Then type import org.apache.spark dot underscore. Dot underscore is used to import all classes and enter all classes of this package. Okay, once package is created, then use create configuration object and pass configuration object to Spark context. Then I am writing all these complete statements into single line. Let's see val here val sc equal to new Spark context. This Spark context takes Spark configuration object Spark conf. Then for configuration, I'm setting set Spark dot master. Spark dot master. So master is I'm setting local machine as a master machine. Next one dot set application name Spark dot app dot name. I think previous class also we discussed the same thing. Once again, let me discuss and continue Spark architecture. Okay, application name is Spark core app. Okay, we set Spark configuration object, and for that one we set local and we set application name, and finally we pass to this object to Spark context. So it is going to create a Spark context object, Spark context object. So it is creating. Once it is created, then what I'm doing, I'm setting set log level, and pass log level. We can set a permanently log level in one of the configuration file, but that is applicable for all the applications in our all applications, right? But application to application log levels are different. That's why it is that is not recommended. So it is recommended. So in application, we will write to set log level. It is recommended because application to application log levels may be different. Okay. So I'm setting log level. Now then create an RDD. Create an RDD. Okay, then rd1 dot count. So 4 records are there. Next rd1 dot collect dot for each and println. So it is printed all 4 records. So we seen how to write Spark application in batch mode. We seen how to write Spark application in interactive mode. I want to see everything in web UI. So while starting Spark context, it is shown web UI. But I want to see web UI. For that one, c dot web URL. If you type this one, it will show web URL. Copy this web URL, go to browser and paste this web URL. You will see everything in web. So we created one is count, right? So click on this count. This is count and this is collect. Click on count. So we loaded file and this is file load. After that we performed what? So it is created one RDD. On that we applied count. So it is only one stage. How it will create stages, multiple stages, we are going to see later. Okay. So it is created only one stage. Yep. So we seen how to write application in batch mode. We seen how to write applications in interactive mode. Now we are going to see what is Spark architecture. What is Spark architecture? So this is Spark architecture. So Spark architecture contains driver, cluster manager, worker node, and executors. Worker node and executors. Each executor executes multiple tasks. So first one, what is driver program? A driver program contains main method. So this is our driver program. This is our driver program. So we are writing driver program. Currently we are running this driver program in standalone machine. Standalone. Currently we are running this one in standalone. In real time, what we will do, once we write this one or once we write this application, once we will test in standalone, then what we will do, we will submit this driver program to cluster manager. So cluster manager, we have a yarn cluster and mesos cluster, right? So we have cluster managers are yarn cluster and mesos cluster. Okay, once we submit this driver program to cluster manager, if it is a yarn assigns the task to worker missions. Yarn assign these tasks to worker missions. Assume we have a two missions. First mission contain block 1, second mission contain block 2. So cluster manager assigns task to worker node 1 and worker node 2. Then these worker missions process the data. Worker missions has a task. So each task is executed by worker mission. Worker mission process this task and returns to cluster manager. From cluster manager to driver program. So this is actual architecture. But currently what we are doing, we are working only in this location because we set master is local and we are executing this driver program in where local mission. So this is called standalone application. In real application, we submit this driver program to cluster manager. Cluster manager is responsible to process that one. Okay, so cluster manager schedule that task and assign task to worker machines. Worker machines are responsible to execute that task. So this is cluster Spark architecture. In this, driver program must contain Spark context. Without creating Spark context, we cannot write Spark programs. We cannot write Spark programs. So this driver program maintains meta information of these tasks. So it maintains which node, worker node executing which task. This worker program maintains that information. Okay. So this is Spark architecture. Okay. In Spark core, in Spark core, in Spark core, RDD is the storage object. RDD is the storage object. Storage object. In languages, we use variables, right, Prasad? In language, we use variables to store data, right? Variables and arrays and collection framework, right? To store data, we use those techniques. In Spark, we use RDD concept. RDDs are data storage objects in Spark. RDDs are data storage objects in Spark. Okay. RDDs are data storage objects in Spark. It whenever we load file into Spark, it is held by RDD. So we create RDDs by loading file. There are multiple ways to create RDDs. We will see one by one. So RDD again subdivided into partitions. RDD subdivided into partitions. We can choose how many partitions for RDD while creating RDD. While creating RDD, we can specify how many number of partitions we want. Assume I want 5 partitions. So it will create 5 partitions RDD. Each RDD distributed across the cluster. So each RDD distributed across the cluster. Assume first RDD is presented in data node 1 or worker node 1. Then worker node 2 may contain RD partition 2. Like that, each worker node contain multiple partitions. Multiple partitions. So here we have created 5 partitions. So each partition stored in different machine in cluster. So RDDs we can divide into partitions. Partition means it's a small piece of data. It's a small piece of data. RDD is a small piece of data. So what is block? Block is a piece of data or chunk of data, right? Similar to that, partition is small data or chunk of data. So RDDs we can divide into multiple partitions. At the time of RDD creation, we can specify how many partitions we want. So each partition stores in different worker nodes RAM in a Spark cluster. Okay. So when we perform any transformation or some processing done on these partitions. So these partitions will execute the transformations and actions. Okay. When RDDs will be executed, this is very important. When RDDs will be executed. In RDDs, we can perform 2 types of operations. in RDD, we can perform two types of operations. One is one is transformations, and another one is actions. One is transformation and another one is action. Okay, so we can apply two types of operations. So when RDD will be created means, when RDD will be executed means, whenever we create an RDD, it will not immediately allocate memory. I am loading file ABC file by using sc.text file. What sc.text file? It will read file from specified location and loads into RAM. But initially, it will not load that file into RAM. Initially, it will not load that file into RAM. When RDD will be created, whenever we apply action. So if you apply transformation also, it will not create RDD memory. When you apply transformation also, it will not create memory. When memory is created, whenever we apply action on RDD, then it will execute from starting to that action. Then it will load that, it will create memory dynamically and executes it. Assume we loaded file 1 and we assigned into RD1. From RD1, I applied transformation 1. I got RD2. From RD2, on RD2, I applied transformation 2. Still it is created one more RDD. In this case, RDD1 and RDD2, memory is not allocated. Memory is not allocated. When memory is allocated, whenever we apply action on any RDD, that time it will allocate memory for RDD. Okay, so RDDs will be loaded into RAM and computed when action is performed. RDDs will be loaded into RAM and computed when action is performed. This kind of execution is called lazy evolution. Lazy evolution. What is the advantage of this lazy evolution? What is the advantage of lazy evolution? Assume we loaded file into RDD1. On the RDD1, I applied transformation. So assume file contain 10 GB or 5 GB. Then on that 5 GB, again I applied some transformation. Transformation result returns RDD. That RDD contain 4 GB. Result RDD contain 4 GB. On that result, again we applied one more transformation. We got from 4 GB to 3 GB. So if when you if you apply transformations on RDD, if it creates memory, it will occupy more memory, right? So that when we apply any transformation, it will not create memory immediately. It will not create memory immediately. When it will create memory, whenever we apply action. Whenever we apply action, it will create memory. Okay. So how many ways we can create RDD? How many ways we can create RDD? We can create RDD in 3 ways. First one, when we parallelize local object. When we parallelize local object, create local object and parallelize. Then it will create RDD. Let me show you this one. I have a local object val list equal to list of values 10 comma 20, 30, 40, 50. I have 5 local elements. So this is local object. Then val R1 equal to sc dot parallelize. Parallelize. Let me see the exact one. Parallelize. Sc dot parallelize, and here I am passing list object. That's it. It is created already. R1 dot count. How many are there? 5, right? So we got 5. R1 dot collect dot for each println. So we got 5 records as output, right? So by using local object, by using parallelize method, we can create an RDD. We can create an RDD. This is one way. And second way, when you perform any transformation or filter over RDD, we get result is RDD. Let me explain here. I have already RDD1, right? R1. From R1, I am applying map. So map implies x plus 10. What will happen here? And every transformation returns another RDD. Map is a transformation. What map do? Map takes input and creates the same output. Map takes input and creates the same output, but applies this custom logic. Whatever the custom logic we written inside a map, it will apply that custom logic on each row. It will apply this custom logic in each row. It means map takes one input and gives output as same. Inside between input and output, we can write custom logic. Whatever the custom logic we are writing, that custom logic executes an input and gives as output. Map is one-to-one mapping. So R1 is a RDD, right? So R1 dot map means it will read each element. So each element name we are calling X. For that each element we are adding 10. So 10 plus 10, 20. 20 plus 10, 30. 30 plus 10, 40. 40 plus 10, 50. 50 plus 10, 60. So you will get that value. R2 dot count 5 records. R2 dot collect dot for each of println. So 10 become 20 become 10 become 20, 20 become 30, 30 become 40, 40 become 50, 50 become 60. So you got it right? You got it right? So map takes input as one record and gives it is one-to-one mapping. We'll discuss this transformation later. What are the transformations are available and what are actions are available. We are going to see our later classes. Okay. So if you apply, second way we know how to create it. First way we know how to create it. Second way we know how to create it RDD. And third way we know already we created Spark context, and by using Spark context dot text file and we pass text file, by loading the text file, we can create RDD. By loading the text file, we can create RDD, right? So this is another way of creating RDD. So totally we have three ways. One, parallelizing local object. Two, when you apply any transformations on RDD, it will return another RDD. It's simply RDDs are immutable objects. RDDs are immutable objects. If you apply any operation on RDD, it will return another RDD. If you apply any transformations on RDD, it will return another RDD. Okay, so we know how to perform all these, right? Next one, operations on RDD. Operations on RDD. We can perform two types of operations on RDD. So entire Spark core programming, we will learn what are the transformations are available and what are the actions are available. What are the transformations are available and what are the actions are available. Okay, so transformation means it to transform one data set to another data form. It will transform one form to another form is called transformation. See, in previous example, first row I have a 10. Once we apply transformation, that is called map. In result map contain 10 become 20, 20 become 30, 30 become 40, 40 become 50, 50 become 60, right? So we are converting one form to another form. Transformation means it's an operation which takes data set as input and transform into another data set. We have different transformations: map transformation, flat map transformation, reduce by key transformation, group by key transformation, filter transformation, filter by key transformation, filter by range transformation. Like this, we have multiple transformations. Popular transformations are these. Next one, actions. Action means what? Action process your RDD and returns the results. Action process your RDD and returns results. Returns results. Action not returns any value. Sorry, action not returns RDD. Action process your RDD returns results. So understand that returns results. Okay, so we have actions like count, collect, take, save as text file. There are multiple actions. There are multiple actions. So tomorrow class, what we are going to do, we will write the Spark core programming. Already we discussed, right? Spark core programming. We'll write some additional Spark core programmings. Then we will understand what is Spark programming and what are transformations and what are actions. How do we use transformations and actions in our Spark application? Okay. Do you have any queries in today's class? So what we will do, tomorrow class will start from Spark transformations and actions. We'll discuss, we'll write Spark core programming. Yep, that's it for today. We'll meet tomorrow.